Good day, everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, today I want to take you through Physical Science Paper 1, particularly on Newton's laws of motions for grade 11 and 12. Ladies and gentlemen, this is one of the topic in physical science, particularly in grade 11. It is one of the topic that has lot of marks. So you need to make sure that you understand it very well. And I believe you'll enjoy the session. This will be part 1 of Newton's laws of motion, where I'll take you through all the concepts that you need to know when you want to address Newton's laws of motion. And ladies and gentlemen, this is my YouTube channel ID. If this is your first time, you can go through this at YouTube. You type at Kangaroo Maths and Science Academy. Then you'll find all the videos that I have already created for mathematics and physical science. Kindly don't forget to like, subscribe, and hit the bell button for future video notification. Without wasting time, let's now start with the session. All right, under these Newton's laws of motion, at the end of the session, a learner should be able to define what is a vector and what is a scalar, and also give examples of vectors and scalar. And secondly, a learner must be able to define what is a resultant vector or what is a resultant force. However, in terms of these resultant vectors or resultant force, I already created a video on how to solve problems that are dealing with, or how to actually determine the resultant force. But this one is particularly for grade 11. So I will encourage you to follow the link that I've shared below for the resultant forces, on how to resolve forces in order to determine the resultant vector. Right, without wasting time, again, you need to be able to know the different kinds of forces that are acting on an object. And also, we are going to go through what is the difference between a free body diagram and a force diagram. And also, one must be able to define what is a frictional force and what is a normal force, and also give examples of a frictional force, give examples of frictional force. And also we must be able to state the Newton's laws of motion. We'll talk about Newton's first law of motion, Newton's second law of motion, and also Newton's third law of motion. And lastly, we're going to talk about the universal law of gravitation. Then again, one must be able to resolve forces or vectors into components using tail-to-head or parallelogram method. Hence, this one I already addressed it in the previous video that I was actually talking about the resultant forces. So there's a link which is being shared below. Kindly go through it in order to enjoy or to know how to resolve forces into components. But I'll also address a bit of that, because this is one of the things that are actually needed when you are solving problems in Newton's laws. And again, you must be able to do calculations using Newton's laws of motion. And again, one must be able to define what is an acceleration. And also you need to know the conditions for constant speed or constant velocity, because these are exam typical questions. These are exam typical questions. So you need to be able to explain, or actually to know these things that are actually mentioned. Let's start with the first one. Number 1, a learner who's in grade 11 or grade 12 must be able to differentiate between a vector and a scalar. But actually, this is from grade 10, but it's just a pre-knowledge. Actually, number 1, let's just go through this. Number 1, you need to be able to know what is a vector. We know a vector is a physical quantity it's a physical quantity. A vector is a physical quantity that has both magnitude. A physical quantity that has both the magnitude, or in another book they call it a size and direction. It must have the magnitude and the direction. Any physical quantity which has both magnitude and direction, it's regarded as a vector. So it must have the magnitude and the direction. For example, if we were to say, I'm applying a force of 20 Newton, then to the right, 20 Newton to the right. So this is an example of a vector because I'm specifying the magnitude and also the direction of that vector. So it's very important to know that when we're talking about a vector is a physical quantity that is both the magnitude and direction. And again, one must be able to know what is a scalar. A scalar, right? A scalar is a physical quantity that has magnitude only, magnitude, or a size only. So a physical quantity that has magnitude only or a size is called a scalar. So in physics, you need to be able to differentiate between vectors and scalar so that it will be easier in the exam. Like if they want you to calculate something, you'll be able to know, okay, it means now that the physical quantity I'm dealing with here, it's a vector. So since it's a vector, it means when I'm doing calculation, I need to make sure that I consider the issue of magnitude and direction. So this is one of the things that are very, very, very important when you are doing physical science. I know I'm addressing concepts for grade 10, but a learner who's in grade 11, a learner who's in grade 12 should be able to remember these things. Right. Again, another thing, ladies and gentlemen, we need to also give examples of vectors and also of a scalar. Right. What are the examples of vectors? I'll start with examples of the vectors. Vectors, example of vector, we have things like a force, which is usually a pull or a push, a pull or a push of an object. So when you are making a pull or you are pushing an object, you are pushing it with a certain magnitude and certain direction, to a certain direction. So that is an example of a vector. And another one, we have what you call the, that's why, okay, fine. I think it's very important to be able to differentiate between vectors and scalars. For example, we have things like displacement. Displacement is an example of a vector because this consider the change in position, the change in position. Then we also have velocity. And remember, velocity and speed are not the same thing. We'll talk about this. We also have acceleration. This is an example of vectors. We also have momentum, the product of mass and velocity of an object. It's also a vector. So these are things that a learner should be able to know or differ. But I know this is for grade 10, but I have to make sure that I address it. And another thing, ladies and gentlemen, in terms of the scalars, remember, scalars are those that has what? Magnitude only. For example, time. We cannot consider time. We cannot talk about time, then we give it a direction. For example, if we say now it's, for example, it's 12 o'clock upwards or right, it does not make sense. It does not make sense because this is the magnitude And specifying the magnitude, the direction on time, it does not make sense. So which means time is an example of a scalar because it has magnitude only. Then things like mass is also a scalar. Distance, yes, distance. It's a scalar because this one we consider the path taken by an object. This has to do with distance. But now displacement is just a change in position. Right now, again, we have what you call speed. Speed and velocity are not the same thing. Yes, they have the same unit. They're all measured in meters per second. Time is in seconds. Mass usually it's gram or kilogram. Distance is in meter. Same applies. The distance and displacement, these two things are not the same thing. So you need to be able to know that sometimes a speed and velocity is not the same thing. Why? Because look, when we are calculating speed is calculated by using distance over time. So speed is distance over time. But look at this. We're taking distance, which is a scalar. It has no direction. We divide by time, which is a scalar also. It has no direction. You see that we're taking something that is without direction and we divide with something that is without direction. It means this will now become a scalar. But when we are calculating velocity, in actual fact, we use displacement and we divide by time. Now you see, because now we use the displacement, it's a vector, it has direction. So we're taking something that is having direction, we divide by a scalar. So it means this will also be a vector. So do you see the difference between a speed and a velocity? That's why if we say, in the exam, they'll say, calculate the magnitude. Calculate the magnitude of velocity. It means they want value only, the size. But if they say calculate the velocity of something, it means they want you to talk about its magnitude and the direction. But if they just say calculate the speed, you know, calculating the speed does not require direction because the speed, it's a what? It's a scalar, ladies and gentlemen. So that's why you need to be able to understand and also be able to differentiate. For example, a force. We have different kind of force which we're going to talk about, and one type of a force which is weight, which is the gravitational force acting on an object. So the weight and the mass are not the same thing. So if they say give the difference between weight and mass, you can say number one, a weight is a vector and mass is a scalar. So this is one of the examples that you can talk about. So it's very important for you to be able to differentiate between a vector and a scalar. And I even gave examples. So time, mass, distance, speed. These are examples of what is this? These are examples of scalar. They have no direction. It's just magnitude only. Okay? I believe you are following. All right. Let's now move on to the second part. Okay. The second one, it says, we need to be able to define the term resultant force or resultant vector. This for both grade 11 and 12. Because in most of the questions, they might ask you, or okay, like you need to be able to tell which one is a vector and which one is a scalar. Secondly, definition of a resultant vector or a resultant force. It depends whether they're talking about vector or a force. Now we know what is a vector. Right, what is a resultant for vector or a resultant force? But this particularly is for grade 11. A resultant vector or a resultant force, it's a single vector or a force, a single vector or a force that has the same effect as all other vectors, you can call it vectors or forces if you're talking about force, as all other forces or vectors added together. So I want to talk about this. A single vector or a force that has the same effect, that has the same effect. A single vector or a single force that has the same effect as all other forces or vectors added together. What does this mean? Imagine, for example, I just want to give an example. Let's say we remember we spoke about a force. We said a force, it's a pull or a push. So let's say we have an object. Is this an example? Let's say we have an object. And on this object, we only have two forces. One force is directed to the right, because remember, we represent a force by having a tail to head. The head is for the direction. I'm going to say a vector. So let's say the first one, F1, the force is 80. Then F2, the force is 30. But now here we want to say, can we come with a single vector or a single force that will have the same effect when we add these together? And that is called a resultant force or a resultant vector. So if here we're going to say, okay, we want to calculate the resultant, the Fres or Fnet. And to do that means we need to make sure, okay, what will be the single vector that we can come with, or a single force that we can come that will have the same effect as this added together. But if you look at this, we know these are vectors, means we need to consider direction. Let's take those that are directed to the right as positive and the one to the left as negative. So let's add this. Instead of adding, we'll end up having this. Because now, remember, we have to just say, okay, we have F1. If we were to add this together, we'll have F1 plus F2. But now these are not moving to the same direction. One is positive, is moving to the right, it means this will be positive, and this one will be negative. So you see that instead of adding, we'll end up subtracting because of that condition, because they're not moving to the same direction. So it's F1 minus F2, which will be 80 minus 30, which is 50 Newton. And because we have taken plus as positive, it means this will still be directed to the right. So which means if we do not want to have this, we can just write one block and say, okay, this block will move to the right with a force of 50 Newton. So you see that this is a single force that will have the same effect as these two forces added together. And that is called a resultant vector or a resultant force. It depends whether they want you to define as a resultant vector or as a resultant force. So it's very important for you to know this. So a single vector or a single force that has the same effect as all other vectors or forces added together, that is called a resultant force or resultant vector. So this is needed for all the grades. So that's why I have to explain them. Okay, now we went through the part of what is this? We went through the definition, the resultant effect. Now let's move on to know the different kind of forces that are acting on an object. It's very important for a learner who's doing who's doing Newton's laws to be able to know the different kind of forces that can act on an object. So it's very, 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 very important. Right, we have different kind of forces that can act on an object. Number one, we have what we call the force applied. Then the second one, we have what you call a frictional force, which we'll talk about. And we have what you call the normal force. Then the other one, we have the weight, the force of gravity, or the gravitational force, weight or force of gravity. But I strongly believe you know this. Then lastly, we have a tension. Let me start with a force applied. A force applied is just a pull or a push of on an object, push or pull on an object. So we're either pulling or pushing an object. But now this pulling, if it's not done using a string, or if it's not done using a cable, or it is not done using a chain, then you know this is a force applied. Maybe we pull something using our hand or any other thing except the issue of using string or cable or a chain, then this will be regarded as the force applied. It's just a pull or a push on an object. Then, okay, I'll talk about these two. The frictional force and the normal force, we'll talk about that. Then the issue of a string, the force on a string or on a cable is actually called a tension. So if you're pulling something using a string or pulling something using a cable or a chain, then it means the type of force that is acting there, it's tension. So these are the types of force that one must be able to know. But I'll explain particularly in terms of the definition. Usually they can ask you to define what is a frictional force or what is a normal force. So weight is just the force or the gravitational force that is exerted on an object, usually vertically downwards. Right, now we'll talk about this. We'll talk about this. And again, we must be able to differentiate between a free body diagram and a force diagram. So we need to be able to differentiate between a free body diagram and a force diagram. But before I talk about a free body diagram, let me talk more about what we mean by frictional force. Okay, let me do this. I want to explain this using an example. Consider an object or a book that is on a table. Consider a book on a table, and this table is not moving, or let's say it's stationary. A book that is on a stationary table. Okay, yeah, let's just consider this. Let's say we have a table, and on this table there is a book on the table. Here is the book on the table. And this object, we just regard it as an object, is stationary. It means not moving at all. Okay, now, first of all, we need to be able to know how many forces are actually acting on this object. Obvious. The forces that are acting on this object will only be two. There will be a force that the object exerts on the table downwards, and that force, because it's the one that the object is exerting on the table downwards, this will be the force. And also we'll still have another force that the table is exerting, or the surface of the table it's exerting on the what? On the object. And both of these forces, the way they are, because this is our surface, they form an angle of 90 degrees with the surface. It means they are perpendicular to the surface. But now, ladies and gentlemen, I want you guys to listen to me very well. The forces that are actually acting here, because the object is not moving, it's stationary. It means these forces that are on this object are balanced. And it's very important to be able to understand what do we mean when we say forces are balanced. We can say we have balanced forces, or we say forces that are in equilibrium. There's a video that I have created on how to solve problems that are in equilibrium. Now, let's look at this. A force or a component of a force at which a surface exerts on an object, and which an object is in contact with it and perpendicular to the surface, then that is called a normal force. So it means here we have a normal force. You can use N or Fn. So, but the force which the object is exerting on the table downwards, this is our gravitational force, or the weight. Now, I want us to talk about what do we mean by a normal force. Okay, without wasting time, and a normal force, it's a component. We can say it's a component of a force, or it's a force actually. It's a component of a force which the surface, remember this is our surface of the table, which the surface exerts on the object, with which it is in contact, must be in contact, with which it is in contact and acts perpendicular, which means forms an angle of 90 degrees and acts perpendicular to the surface. So let me explain this so that you can be able to understand. Remember I said on this object, because the object is actually stationary, not moving, it means here we are going to have forces that are actually balanced, or forces that are in equilibrium. Now, it means that how many forces are actually acting on this object? It's only two forces. There is a force that the surface of the table, it's exerting on an object, but they should be in contact with the object. And this force is perpendicular, which means forms an angle of 90 degrees. Then that force is called a normal force. So a normal force is a component of a force which the surface, you see, it is the surface that is exerting on the object, or on an object, with which it is in contact So they should be in contact and do what? Act perpendicular to the surface. So it's very important to be able to define this. Usually in the exam for both grade 11 and 12, they can ask you to define what is a normal force, the component of a force with which the surface exerts on the object, with which it is in contact and acts perpendicular to the surface. That is a normal force. So it means the weight, it is the components of a force which an object exerts on the surface, in which it is actually vertically downwards. Right. It shouldn't be a case that force of gravity will be there when the object is in contact. No. Force of gravity can still be there even the object is hanging. So it's not a mass that it should be in contact with the surface. Okay, now we are able to know what is a normal force. Right. Since I said one must be able to know what is a frictional force and what is a normal force. Let me explain what is a frictional force. A frictional force is a force that opposes the motion of an object is a force that opposes the motion of an object with which it is in contact and acts parallel, not perpendicular. It acts parallel to the surface. I think what is important here is to be able to know that we're talking about the one that opposes. The force that opposes the motion of an object with which it is in contact and act parallel to the surface. It acts parallel, not perpendicular like normal. So a frictional force is a force that opposes the motion or the direction of motion of an object, and it acts parallel to the surface. What does this mean? It means that the frictional force actually takes place when the object, either the object is in motion or not in motion. But we need to understand something here. Now we said the object initially had what? Had a normal force and also a force of gravity, which are balanced for now, okay? Then now, if we say this surface, it's rough, and the object is being pulled, just give an example, the object is being pulled to the right with a force applied. Then since the object will move to the right, there will be a force that will oppose this object, the motion. Obviously, will move in the opposite direction. And it must be in contact and it must act parallel to the surface. And that is called a frictional force. So a frictional force is the force that opposes the motion of an object with which it is in contact and act parallel to the surface. That is called a frictional force. But ladies and gentlemen, under this frictional force, there are two types of friction that you need to know. We have what you call a kinetic frictional force and static frictional force. As the word says, static has to do with things that are stationary. Kinetic has to do with things that are moving. Okay, let's talk about this. I apologize. There are two types of frictional force that one must be able to know, particularly when you are preparing for an exam. So you need to be able to define what is a static frictional force and what is a kinetic frictional force. Yes, frictional force and Static and kinetic, they both oppose. They oppose the direction of motion. But now let's talk about what is the static frictional force. A static frictional force, it's a force that opposes the tendency of a stationary object relative to the surface. So a force that opposes the tendency of a stationary object relative to the surface. And we can also say which act parallel to the surface, because it's still a frictional force. Let me define then, because we'll talk about this. Then the kinetic frictional force is a force that opposes the tendency of motion, I apologize, of motion. Okay, guys, as I was saying, I had connection issue, I apologize. I was talking about the definition of static frictional force. Under the static frictional force, we said a static frictional force is a force that opposes the tendency of motion of motion on a stationary object, of motion on a stationary object relative to the surface. So a static frictional force, as I said, is the force that opposes the tendency of motion on a stationary object relative to the surface. Whereas kinetic frictional force is a force that opposes the motion of a moving object relative to the surface. The force that opposes the motion of a moving object relative to the surface, that is called the kinetic. But that opposes the tendency of motion on a stationary or of a stationary object relative to the surface, that is called a static frictional force. So it means we deal with static frictional force when the object is not moving. That friction that is resisting the object not to move, it's all called the static frictional force. Actually, we call it a maximum frictional force, static frictional force, where we use the coefficient of static friction, then we multiply by the normal force. I believe you know this. Remember, mu s is called the coefficient of static friction. Then the n here is the normal force, which means the frictional force depends on the normal force. But for kinetic, mu k would be mu s, I'm saying Fk would be mu k times n. This one is for a kinetic frictional force. I apologize. And it's very important to be able to know that this one is called the coefficient of kinetic friction. And you must know that this coefficient, the mu has no unit. Why? Because it is the ratio of frictional force and normal force. Since it's the ratio of friction and normal, so if you make, let's say we have F, it's mu times n. If you mu this, we make mu the sum, it means divide by n here. So you see that the coefficient of friction will be force over n. All of these are forces, so they're all measured in Newton. So you see that the units will divide. That's why this has no unit. So it is the ratio of friction force and the normal force. That's why it is no unit. So in the exam, you must be able to define what is the frictional force. Is the force that opposes the motion of an object with which it is in contact. And it acts parallel to the surface. But again, in the exam, particularly in grade 12, they can ask you to define what is the static frictional force and what is the kinetic frictional force. So you need to be able to define this. Okay. Right. Now we have to move on to the next part. Remember this part, actually, I'm just going through what is necessary for you to, when you are doing calculations. And in the next video, then we'll start with the problem solving. Okay. Right. Then next slide, then next part, we will talk about the difference between a free body diagram and a force diagram. Right. If we do this, let's go back to what I just said. Already, we addressed, we went through the vector. The vector, resultant force of vector, the kinds of forces. Now we're going to talk about, you must differentiate between a free body diagram and a force diagram. Let's consider an object. Let's consider the same object which was stationary. The same object which was stationary, how many forces were acting, by the way? On the table, we said there are two forces. The first one was what? Table, which is stationary. This is the surface. We had a force that is exerted from the surface, exerted to the object, which is the normal force. And also we have the force of gravity. Here they're balanced. Okay. So they're balanced now. Okay, vertical up and vertical down. So this is the force of gravity and this is the normal. They are balanced. So now we want to differentiate between a free body diagram, and a force diagram. In a free body diagram, when we are dealing with free body diagram, instead of drawing the shape or the object, we actually use a dot. We use a dot to represent the object of interest. So we use a dot to represent the object of interest. But in a force diagram, yes, even though we show all the force, but in a force diagram, we draw the object. We draw the object, or we draw a box to represent the object of interest. So instead of using a dot in a force diagram, we just use a box, but we indicate all the force will be present in both. For example, if I just put a dot instead of just drawing that, then within the dot, then I show all the forces. We'll have this, and we'll have that. It should be roughly the same. Okay? So we'll have something like this. So it will be the normal and the FG. We show all the forces, but we use a dot to represent the object of interest. But in a force diagram, we do not use a dot. We draw the picture of an object. We draw the box. We use a box, actually. I apologize. And within the box, what do you do? Okay, there's no need to do that. We also indicate all the force that actually acting there. So it's still the normal. And we still have the force of gravity. So we represent all the forces, but this time around, we use a box. We draw the box to represent the object of interest. So that's the difference between a free body diagram and a force diagram. And remember, I said this forces because the object is what? It is stationary, which means the objects are balanced. And remember, I said objects that are balanced means they're in equilibrium, which we're going to talk about. And systems that are in equilibrium, it means their net force is 0. So which means since these are balanced, but they're not directed, one is upward and one is downward. So the net is going to be the normal minus FG. This should be, what does this mean? It means the normal and FG are equal. Yeah. When we say they're balanced. So it means the upward force is equal to the downward force. We'll talk about it. We'll talk about this. Let me not confuse you for now. Okay? All right. Let's now move on. Now we are able to differentiate between a free body diagram and a force diagram. Right, next. Next one is the issue of defining what is a frictional force and normal force. We define that. We went through the definition. We defined that. Then now we have to look on like the Newton's laws of motion. And guys, this is very important. You must always, these are just free marks in the exam. Number one, we have Newton's laws, first law of motion, which we call it the law of inertia. The law of inertia. Let's talk about this. Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and also the universal law of gravitation. You need to be able to state these laws. You must be able to state them because this one in the exam, they can either ask you to state one or two. So you need to make sure that you know how to state the laws. Let's talk about Newton's laws of motion. Number one, I'll talk about Newton's first law of motion, which you call it the law of inertia. Right, what does Newton's first law of motion says? Newton's first law of motion states that an object An object will remain in its state of rest, or will remain at rest, or continue. The object will remain at its state of rest or continue to move at a constant velocity unless a non-zero, sometimes they say a non-zero or a resultant, a non-zero, let me say a non-zero resultant, a non-zero resultant force or a net force acts on it. On the object or on it. Right, what do you mean by this non-zero force? Obvious, a non-zero, when we have a resultant force, when we have a resultant force or an F force that is not zero, it means we are dealing with forces that are actually unbalanced. Remember, I indicated something to say forces that are actually balanced. It means they are in equilibrium. And forces that are in equilibrium, it means the net force or the resultant force on that object, it's zero. But listen to what Newton's first law of motion says. It says an object will remain in its state of rest or will continue to move at a constant velocity. It will continue moving at the same velocity unless a non-zero resultant force acts on it. Sometimes they say unless an unbalanced force acts on the object. It's also fine. So an object will remain in its state of motion. An object will remain in its state of rest or continue to move at a constant velocity unless a non-zero resultant force acts on that object. That is called the Newton's first law of motion. And again, why am I saying this is called the law of inertia? Inertia is the tendency of an object to resist its state of motion, to resist in its state of motion. So this is called the law of inertia. And this inertia, it's actually affected by the mass. The mass of an object is the one that causes this process of inertia. That's why, for example, imagine you are in the car and this car is traveling at the speed of 120 kilometers per hour. Obvious, according to this, it says the object will remain in its motion state of rest or will continue moving at the same velocity unless then the resultant force or the net force that is acting on this object, it's no longer zero. So something external or an external force acts on an object, then the object, yes, it acts on an object. So obvious, that's why some of the things they say it's very important by using this law. It's very important to know that any object that is inside this car, it's also traveling at that speed of 120 kilometers per hour. That's why if you do not wear a seatbelt and anything happen along the way, you're still gonna continue with the same velocity. Then now, that is according to the Newton's first law of motion. But we'll talk about this. This is Newton's first law of motion, which says an object will remain in its state of rest or continue to move at a constant velocity unless a non-zero resultant force acts on the object. That is Newton's first law of motion. It's imperative to be able to define this. Imagine a grade 12 learner not knowing to know how to define first law of motion, second law of motion, third law of motion. Free marks. They're just free marks. So you need to be able to state Newton's first law, Newton's second law, and Newton's third law of motion. Now, number 2, Newton's second law of motion. And this is one of the most important law because in most of the calculation, we use this law. We use Newton's second law of motion when we are doing calculations. Newton's second law of motion. According to Newton's second law of motion, is comparing the net force that is acting on an object with the mass and the acceleration. And this is one of the most important law in physical science. Because the issue of, if we were to change back to the issue of momentum, this for grade 12, there's a formula which it was proved using this, which is changing momentum over changing time. They've used the formula, but we'll talk about that when we will talk about momentum for grade 12. Right. What does Newton's second law of motion says? Newton's second law of motion states that when a net force, or we can say a resultant force. I believe you know what is the resultant force. When a net force or a resultant force acts on an object, it will cause, when a net force or a resultant force act on an object, it will cause the object to accelerate when a net force or resultant force act on an object causes, you can also say cause an object instead of saying it will cause, still fine. Cause an object to do what? To accelerate in the direction. In the direction of the net force, or you can say in the direction of the force, in the direction of the force at an acceleration, that is directly proportional. That is directly proportional to the net force, proportional to the force or to the net force, and inversely proportional to the mass of an object. So what does this law say? It says acceleration and the net force are inversely proportional, are directly proportional. So I apologize. The acceleration and the net force are directly proportional, but the acceleration and the mass are inversely proportional. So what does this mean? It means if we were to compare acceleration and the net force, they will be directly proportional, directly. So you increase acceleration, you increase the net force. But acceleration and the mass are inversely proportional. That's why these end up having F net equals to MA. And by the way, guys, maybe you don't know this, that if they say state Newton's second law of motion, in reality, this is still the same as you can state Newton's second law of motion in terms of momentum. They will not gonna penalize because it's the same thing. If you say when a net force, the net force on an object, the net force on an object is equal to the rate of change in momentum of that object. Still the same thing. It's still the same as when we say the net force or the resultant force when it acts on an object. It will cause the object to accelerate in the direction of the force or the net force at an acceleration that is directly proportional to the net force and inversely proportional to the mass of an object. Or you can say the net force acting on an object is equal to the rate of change in momentum. So you need to be able to know that these two things are the same. But for now, let's focus on this one. And this is one of the most important law in physics, especially in Newton's laws. Because we use this formula in calculation. So usually they like to ask this second law of motion. Just free marks, guys, free marks, physical science, free marks, grade 11 and 12. Now, let's move on to Newton's third law of motion, action-reaction forces, or action-reaction law. Newton's third law of motion. According to Newton's third law of motion, Newton's third law of motion, it reads thus: when object A, or if object A, let me just say if object A exerts a force on object B, object B will simultaneously exert a force on object A of equal magnitude. Of equal magnitude and in opposite direction, or but in opposite direction. This is action-reaction force. So what does this mean? Imagine there's a hole here. This is just a hole. And you are applying a force on the hole. So this is the force exerted by you. Let me say it's A. A is exerting a force on B. Then it means here you are applying a force on B to the right, on B is the wall, then even B will, if this object is not moving, the B will exert the same force on you, but in what? In opposite direction. Of equal magnitude, but in what? In opposite direction. That is according to Newton's third law of motion. It says, if object A exerts a force on object B will simultaneously exert a force on A of equal magnitude, but in opposite direction. Or end in opposite direction. There's no problem with that. So it's very important for you to understand Newton's first law of motion, which is called the law of inertia. Newton's second law of motion, which we use F net equals to ma, and the Newton third law of motion, which is the action-reaction force. Action-reaction law. So it's very important for a learner to be able to define this. These are just free marks, ladies and gentlemen. We know they will ask you either first or second or third, or even the universal law of gravitation. So you need to make sure that you know how to state these laws in words. It's very important, very, very important to state Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Remember, repetition is the mother of knowledge. Newton's first law states that an object will remain in its state of rest or will continue to move at a constant velocity unless a non-zero resultant force acts on the object or that object. This is called the law of inertia. Now, second law of motion, it states that when a net force or when a resultant force acts on an object, the object will accelerate in the direction of the net force at an acceleration that is directly proportional to the net force and inversely proportional to the mass of that object. And I know you know what you mean by direct proportion. Increase in one variable result in increase in the other. Inverse proportion, decrease in one variable, the other variable increases. Then the Newton third law states that if object A exerts a force on object B will exert the force on object A of equal magnitude but in opposite direction. Universal law of gravitation. So the one that I was just talking about is the Newton third law of motion. Let's now move on to universal law of gravitation. Universal law of gravitation, it's much related to the Coulomb's law, but not necessarily the same, but I'm just saying it's related to Coulomb's law. And according to the universal law of gravitation, it says everybody in the universe, each body in the universe, will attract other body. Each body in the universe will attract other body with a force that is directly proportional to the product or to the magnitude of the product to the product of the magnitude of their masses and inversely proportional to the distance, between their centers, not between them, between their centers. So it means we'll talk about between them if you're talking about Coulomb's law, which says the magnitude of the electrostatic force from one point charge to another is directly proportional to the product of the magnitude of their charges and inversely proportional to the square, proportional to the square of the distance, okay, to the square of the distance between their centers, or between them if you're talking about electrostatics, I apologize. The square of the distance between their centers. Proportional to the square of the distance between their centers. So each body in the universe will attract other bodies with a force directly proportional to the product of the magnitude of their masses and inversely proportional to the square of the distance between their centers. This is universal law of gravitation, which says that F equals to the G m1 m2 divided by r squared, where the G is the universal constant. Then the m1 and the m2 is the masses in kilogram, the r is the distance between them. So you need to know that when we say inversely, it means if you increase the distance, the force will decrease. So they're inversely proportional. But if you increase the mass, the force will increase. So this is according to the universal law of gravitation. And one other thing you need to be able to know that different planets have different gravitational acceleration. Remember, we know the gravitational acceleration on Earth, it's roughly 9.8 meters per second squared. Because we use the formula G equals to the gravitational constant multiplied by the mass of the planet divided by the square of the distance. So that's why if we multiply here by the mass on Earth and the radius on Earth and also the gravitational constant, it will give us roughly 9.8. So you see that different planets have different gravitational acceleration. That's why when we calculate gravity, the weight, force of gravity, using the formula F equals to ma. The force of gravity, when you put the force of gravity, the A will be the G. So the gravity will be 9.8. So this is the formula for calculating weight. We use mass multiplied by gravitational acceleration. Remember, different planets have different gravitational acceleration. We'll talk about this. Okay, now I believe we are able to state Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and the universal law of gravitation. Remember, in the next part, we are just going to solve problems relating to this for both grade 11 and 12. So here I wanted to take you through all the things that you need to know if you want to enjoy Newton's laws of motion for grade 11 and 12. Okay, let's move on. Now we went through. Now I wanted us to talk about how to resolve forces into components using tail-to-head or parallelogram method. Remember last I said, if you apply a force, but not necessarily a force, but if you exert a vector, and this vector which you are exerting, you are actually exerting it at an angle. Let's call this F. It's now at an angle. Let's call the angle. It's now at an angle. Let's call the angle theta. Remember, you need to know something when you are dealing with Newton's laws. Any force that acts at an angle, any force that acts at an angle need to be resolved into components. Unless if you are just dealing with work, energy, and power, then there's no need. You can either resolve or don't resolve. So any force that is acting at an angle, you need to resolve that force into component. And to resolve the force into component, it's either use the method the tail-to-head method. And what does the tail-to-head method say? It says, where there is a tail, remember this is the tail, this is the head. So you start with the tail, then you come with the head. And when there is a head, you put another tail. It depends on where you want it to go, downwards to the right, but you use tail-to-head method. And where there is two heads and two tail, already it is our resultant, is the resultant. Let's do this. I want us to have tail-to-head here. Already this is my tail. This is my tail. And this is the head. So I want to use tail-to-head method. And if I want to see that I've done it correctly, here I must have two tails. And here I must have two heads, if I have done it correctly. And to do that means if I want two tails, already there's a tail, it means I have to put another one here and say, okay, tail to head. Tail to head. And where there is a tail, a head, I have to put another tail here. Then I come this side. Okay, let me just do this. And to see that I have done it correctly, I must have how many heads? Two heads and two tails. Then it means this is my resultant. And since these are my resultant, means there will be an angle of 90 degrees. And it means these two will be the components of the first one. So which means this one, because if we were to draw a Cartesian plane, this is on the x-axis, and this one is on the y-axis. We can also use a Cartesian plane to represent that, so that you can understand what I'm actually talking about. So if we wanted to use a Cartesian plane, we can say, okay, fine, it's our Cartesian plane. So I'm going to say, okay, from this is my tail. So I'm going to say, okay, I have tail to head. From here, I put another tail, then head up. So tail, head up, okay. Then this is what we're going to have. So it's tail to head, tail to head. Then now, where's my resultant? My resultant is from here, the starting point to the finishing point. So you see that the angle that I was actually talking about is the theta. So you see that within this, we can call this our resultant. So it means this is the horizontal component. This is the fx. And this is the fy. So it means here we have components of our resultant, which is f. And what is our component? We have fx and we have fy. To avoid doing this trigonometrics, you can say, okay, fine. Since these are the components of f, it means f is part of the equation. It's our hypotenuse. The only difference is that one should use sine and one should use cos. And to do that, we look at our angle. There is our angle theta. Now we identify the opposite. The opposite of this angle is this one. I'm saying the opposite side of the angle is this one. And this one is our hypotenuse, which means this is the hypotenuse. I'm saying, I apologize. It is our adjacent, this one, this. So this is the adjacent, this is the hypotenuse. So we know once it stays opposite, we know in terms of regard to a sine, it's opposite over hypotenuse. So the hypotenuse is already, it's our f. So it means this one will use sine. If it's opposite, if it's the opposite, then this will use sine. So it means this will be sine theta. So we have sine theta for Fy. Then this will become cos theta. So like it's the cos because it's the adjacent. This is the opposite because hypotenuse already, we have included it. But this is called tail to head method. But one can do this. Instead of using tail to head method, we can even use parallelogram to say, okay, fine. In grade 11, where there's something called equality of vectors to say, if you have a vector here, from here, this is a vector, we can still move it and put it there. In another book, they call it tail to tail. Tail to tail. Parallelogram is also called tail to tail. Let me show you how to deal with tail to tail method. So with the tail to tail means their starting point should be like this, okay? So we have something like this. There's our Cartesian plane. Then we have something like this. So we can do this from the same tail, then we have a horizontal, and there we still have a vertical. So let's call this fx, and let's call this fy. So in terms of parallelogram, it's say, okay, fine. From here, we can still incorporate tail to head. If we say tail to head up until here, then we still have another one there. So you see that this one is the same as our fx. And even if we can use horizontal tail to head, then tail to head here. Then you see that our resultant will be from here, up until there. So you see that it's either we use this other part or the other part. It will still have the same thing, parallelogram method. But usually the general one is the tail to head method. So any force that is acting at an angle should be resolved into components. For example, let's say we are told that there's an object here. And this object is being pulled horizontally, but at an angle. Let's say the force here is 800 Newton, but it's being pulled at an angle of 30. You see, now we need to resolve this into components. And to do that, we can use tail to head. It's okay, this is the tail, this is the head. So we need another head here. So we're going to say tail to head and tail to head. With how many heads? 2 heads, 2 tails. So we're going to call this, because this is the horizontal, we're going to call it the FH or FX. And this will be the FY. So we have the components of F, which is the FX, and which is the FY. Both are components of the resultant. So it means they will both have F. The only difference is that one uses sine and one uses cos. So to do that means we're going to simplify. Which one uses sine? We look at the angle. Angle 30, what is the opposite? Is Fy. This is the opposite. It means the opposite to Fy is the one that uses sine. This one is adjacent. Adjacent is the one that uses cos. So we know our F is 800, so it's going to be 800 cos 30 and 800 sine 30. So this is important for both grade 11 and 12. 800 sine 30, this one will be 400 Newton. Then 800 cos 30, this will be 692.82 Newton. If we were to specify the direction, we will say this is directed right. This is directed upwards. You need to indicate this arrows. So it's very important to be able to know how to resolve forces into components. There's a video that I already created below, particularly for grade 11. You can watch it and do your calculations. Or you just go through it to understand how to resolve forces. This is for both grade 11 and 12. It's very important. Then again, since now you are able to resolve forces into components, let's now continue and talk about the other aspect. Like again, one must be able to do calculations that using Newton's laws of motions. Obvious, in terms of using Newton's laws of motion, it's the issue of, particularly when we are solving problems, we use Newton's second law of motion. And you need to understand that the direction of forces matters. Direction of vectors is very important. Are important. For example, an object that is moving or a force that is directed to the right will not have the same effect with the force that is directed to the left. If you choose right as positive, it means this has to be negative. So it's very important. The direction of vectors are important. And when we are doing calculation, you cannot just calculate the net force of vectors that are horizontal and vertical, then you just add them. It's unacceptable. More video, like there will be a video where we are just going to solve problems relating to this. And also the universal law of gravitation. All right, the second last is the issue of knowing what we mean by acceleration. I think when I was teaching, what is this? There was a part where I was talking about like any formula that has time, it's easier to define it. I think it's a part of our rate of action. Right, first of all, you need to be able to know what is acceleration. When we are calculating acceleration, we are looking at the changes in velocity. The changes of velocity in relation to time. So now, acceleration is final velocity minus initial velocity over the time. That's why we say acceleration is change in velocity over change in time. So these, you see that I said in physics, any equation that has time in it, especially at the denominator, when you are defining it, you talk about the word rate. So what is acceleration? Acceleration is the rate of change, is the rate of change of velocity. Now, let's do this. Let's say we have an object, and this object initially had a velocity of 10. Maybe after some time, let's say after 0.2 seconds, the velocity of the object now, let's say it's 20. It's doubled actually. You see that the velocity has changed. Why am I saying velocity? I'm now talking about the direction. They're all moving to the same direction. So acceleration, we know, is the change in velocity over change in time. And what is the change in field velocity? Final minus initial. Change is just final minus initial. So what is the final velocity? 20. Initial is 10 over 0.2. So it means the acceleration will be how much? 10 divided by 0.2. This will give us 50 meters per second squared. You see that here the acceleration is not 0. The acceleration is not 0. But now let's look on the case when we have this. Let's look on a case where the object is moving from one point to another, but with a constant velocity. You see, from A, now it is at B, and it traveled for 0.2 seconds. Its velocity at the start was 10. And at the end also is still 10. Is it changing the velocity? Is the velocity changing? No, the velocity is constant. There is a constant velocity. Now let's check. The velocity initial was not, well, like it changed from 10 to 20. Now the velocity did not change. Now we're gonna say, okay, fine. How do we calculate acceleration? Change in velocity over change in time. Final minus initial over the time. Final is 10. Initial is also 10. So it's 10 minus 10 over 0.2 seconds. What is the acceleration now? 0. So we can ask ourselves, what causes the acceleration to be 0? What causes the acceleration to be 0? Obvious. The thing that causes acceleration to be 0 is when there is a constant speed or when there is a constant velocity. If the velocity of an object is not changing, or if the speed of the object is not changing, if you're not considering the direction, then it means the acceleration will be 0. And ladies and gentlemen, these are some of the tips that the examiner gives you. Actually, sometimes they write it in capital letters so that you can be able to see. So which means that when the conditions for constant speed or constant velocity, if we have a constant velocity, it means the acceleration would be 0. The acceleration would be 0. All the time, constant speed or constant velocity means acceleration is 0. Acceleration is 0. Constant speed or constant velocity means acceleration is 0. And these are exam typical questions. And by the way, when acceleration is 0, even the net force that is acting on that object will still be 0. And what does this mean? It means we know, and we went through that, when the net force is 0, it means the forces that are actually acting there are actually balanced, or they are in equilibrium. Why? Because even if we know the mass of the object using Newton's second law of motion, but as long as we have a constant speed or velocity, acceleration is 0. And anything that we multiply by 0, it will still become 0. Now the grade 12s. Now the grade 12s. That's why you need to link Newton's laws and work energy and power. Obvious, if the net force is 0, even the net work done on the object will still be 0. Why? Because the net work done on an object, it is the net force multiplied by the displacement, the cos of the angle between them. But since the net force is 0, it means even the work net is 0. But this is for grade 12, work energy and power. So in most of the case, guys, don't just take the formula and start writing. Understand what you are doing. For example, let's say you forgot on how to define acceleration. You can go to the equation of motion in your formula sheet. There is this formula, VF, it's VI plus A change in T. From the equation of motion, let's make A the subject of the formula, the acceleration. Obviously, we'll transpose VI to this side. This will be VF minus VI equals to A changing T. Then you divide this by changing T, and you divide that by changing T. You see that your A will be VF minus VI over changing T. And what did I say about VF minus? It's just change of velocity over. You see that acceleration is the rate of change of velocity. I believe, guys, you are following. So now this was just part 1. So it means in part 2, we are just going to solve problems. Ladies and gentlemen, when you don't cram physics, you need to understand what you are actually doing. Physics is one of the easiest, actually, let me say, compared to maths, this is one of the easiest chapter, easiest subject, only when you know what you are doing. It's not about just taking a formula and plugging and solving. It's about understanding what you are actually doing. In summary, grade 11, you must be able to differentiate between a vector and a scalar. Physical quantity that has both magnitude and direction is a vector. The one that has magnitude only is a scalar. One, again, must be able to define what is a resultant vector or a resultant force, single vector or single force that has the same effect as all other forces or vectors added together. You must know the different kind of force that are acting on an object. You must be able to differentiate between a free body diagram and a force diagram. You must be able to define what is a frictional force and what is a normal force. You must know the different kind of frictional forces. And you must be able to state Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and the universal law of gravitation. You must be able to resolve forces or vectors that are like into components, either by using tail-to-head method or parallelogram method. Also define what is an acceleration, the rate of change in velocity of an object, and also be able to know that when they say constant speed or constant velocity, acceleration is zero acceleration. Ladies and gentlemen, this is the end of the session. We'll meet again in part 2 of Newton's law of motion. Thank you for listening. Don't forget to like, subscribe, and share. Bye-bye.